Okay.
Liquid nitrates here for your fingers.
Yeah.
What else? What else?
Okay, guys. We're going to go through. All right, guys. What we're going to do is we're going to go through that list of rules, and some of you are kind of going. When we went through, that was an overview. Okay. So we're going to take each one, and we're going to teach you how to do each step one at a time. Okay, and then we'll pull all this together. And I am going to go ahead and record the screen and the audio for the benefit of those people who are gone. Been playing with that in AP a little bit, and it seems to be kind of working. We're fine-tuning the thing here. So audio is getting recorded here. So I'll back up just a little bit. Carlos?
Is the guest speaker Tuesday right after?
Oh, yes. Let me talk about the guest speaker for just a moment, because that definitely applies to this group. Tuesday after spring break, Sophia Percival, who was in this class actually, she graduated in 2005. She is an engineer at Cook Pharmica. She kind of works in chemical engineering, but she actually majored in biomedical engineering. So she's going to talk a little bit about both. It's probably more biomedical, I guess, than anything. But biomedical and chemical engineering and some stuff that they're doing at Cook Pharmica. She's going to be here to talk for a while and then answer your questions and bring, I think she said she was going to bring a couple of things to show. So that's coming up on Tuesday after spring break. So if you wait and sign up, you know, that Sunday before spring break, you're probably, or at the end of spring break, you probably won't remember. So I just got on at lunch and they have it up, so you can sign up now. This morning you couldn't. I took a list, and those people, if you're in AP, I already got you in. If you want me to assign you, I will. But you can go in and sign up for that on Tuesday in this room, Panther Plus. And then on April 2nd, we're going to have another one. Another former student of mine. He didn't graduate from here, though. He is an associate professor of physics at IU. He does particle physics. He's actually worked at CERN, which is where the Large Hadron Super Collider is, if you've heard about that. And if you watched that episode of Big Bang Theory where Sheldon throws a fit about not being able to go and get sick and everything, yeah, that's it. He actually worked over there. He does some particle research here and at Cornell, which is where he got his PhD. And he's also working on a new lab over in China. So he actually commutes to China and commutes to Cornell, which is kind of strange. He'll go for like the week and come home on the weekend. And then he teaches physics, and they've got him on like a rotation. So one year he does one, and one year he does the next, and so it just kind of rotates around. But anyway, he's going to be here on Tuesday, April the 2nd. So that'll be coming up. But Sophia's going to be here talking about engineering and science on Tuesday. So if you want to sign up for that, it's under careers in science, I think is how they listed it. And it's got my name on it for Tuesday. So sign up if you're interested. And Sophia's pretty entertaining usually, so I'm sure that'll be good. So, yeah, don't forget about that. Does that answer everything? Okay. So she'll talk about what's going on there. Okay, so speaking of some biomedical stuff, carbon chains. First of all, you want to find the longest continuous chain of carbons, okay? And don't be fooled when it, you know, twists and turns around. It doesn't have to be a straight line. When we draw them, we like to draw them in a nice, neat, straight line. But they don't always work that way. So be sure that you follow it all the way around. Oh, thank you. My signs about the career thing. So make sure you follow it all the way around. Okay? Make sure you get the absolute longest continuous chain of carbons. Now, the H's, don't get fooled by the H's. And that was one of the things that I wish someone had pointed out to me the first couple of days of organic when I took organic. That this CH3 here really isn't, the H's are not in that chain. It's the carbons that are attached, not the hydrogens. So, for a while, it may help you to draw out CH3 and draw it like this, and then CH2 and CH2. It may help you to draw those hydrogens out until you get a feel for it, okay? CH3 is just a lazy way of writing this. And then CH2, CH2, okay? And I wish someone had done that and actually put that in a Lewis structure for me, at least to start with, so that way I know, oh, okay, that hydrogen really isn't here. The hydrogens are around it. Yeah.
Can you go back to the slide we were just looking at? How does that CH2 work there? It's the third one into the, yeah, how?
Yeah, so if I draw this out, close this.
Okay,
Yeah, now I can
it's
draw
not
it out.
hosting two other hydrogens, is it?
Yeah, so the carbons are like this.
Yeah, but like
Yeah.
the third carbon, how is that
I'll
holding?
get there. Okay, so this is CH3. This is CH2.
That's
Now
already on
this,
3 times.
yeah, that's a typo.
That's a typo? Are we breaking the
Yeah,
octet?
because you're not breaking the octet rule.
Like, how
No.
does carbon do that?
No, so that's a
That's a typo.
typo.
Good.
Yeah.
Okay. Freaks me out.
Yeah. So
I saw that yesterday and I was like, what's
yeah,
going on?
yeah, that's a typo. So you get the idea here.
And then there's
Okay.
another CH2 on the other one.
Yeah. The thing to remember is carbon has 4 bonds. So again, you don't have to always draw the official Lewis structure and do the count and everything, because carbon has 4 bonds. So you always count up to 4, and that's how many hydrogens you put on. Somebody didn't count to 4 very well, apparently.
There's one on the other one too.
Is there one on the other? Oh, yeah. Now see here they caught it, but apparently here they didn't. So whoever I stole that from.
Well, that isn't like a
Goofed
3D structure or something.
Oh yeah, this is all
Maybe
3D too.
okay.
Yeah. So all of those are tetrahedral. Every one of those carbons is tetrahedral. So all those tetrahedrals are all lined up. So yeah, somebody didn't count to 4 properly. Always count to 4, okay? You take all the bonds, if there's a double bond or a triple bond or whatever, count those and then add hydrogens until it gets to 4. That's really how you can do the Lewis structures. You don't have to go through and add up the total and do all that stuff, because carbon always makes 4 bonds. So you just add hydrogens until you get up to 4 bonds. So if it's a triple bond, you add 1. If it's a double bond, you add 2. If it's a single bond, you add 3. If it's on the end, and then if it's connected to another carbon, then you have to take 1 away, the hydrogens. So that's why it goes CH3 on the ends, but then CH2 here, and then the intersections, they're CH. So, yeah, good point there. I never noticed that. But, yeah, they goofed up on this. Okay, so find the longest chain of carbons, and that's probably why, because I was just looking for the longest chain of carbons, but, yeah. Okay, so that's step one. We went through the prefixes that tells you how many carbons there are. From 5 on, you should kind of know those already. You just have to really memorize the first 4 from scratch: meth, eth, prop, and bute. And then the rest of them should be familiar to you. The ending, remember, ane is the parent chain, all single bonds. Ol is a group that's attached to it. So here is my parent chain. This is the longest continuous chain of carbons right here, 5. So this is my parent chain. That's the longest chain of carbons. And then everything else is attached to that parent chain. So that part that's circled in red there, think of that as a pendant. Think of that as an attachment to that parent chain. Now that attached group has 2 carbons on it, so that's an ethyl group. Okay? So that's an ethyl group that's attached to pentane. Now the 3, we'll get to that later, but the 3 tells you where on pentane that ethyl group is attached. Okay, because that ethyl group could have been attached somewhere else. So the 3 is there just to tell you, hey, it's on carbon number 3 of the parent chain. 1, 2, 3. So this is attached to number 3. Okay, so we'll get to that. Okay, and this is where we were, I believe, numbering the parent chain is step 2. So step 2, you number the parent chain. Now, you can go forwards or backwards. Okay? What you want to do is you always want to give the groups that are attached the lowest number that you can. Okay? So on this one, my longest continuous chain of carbons is once again 5. Okay? It's right here. This is an attached group. So I can number this 1, 2, 3, 4, 5, or I can number this 1, 2, 3, 4, 5. The first way is better because that would put the methyl group that's attached to the parent chain on number 2, where if I did it backwards it would be on number 4. Okay, so I've got the green way where it would be on number 2, I've got the red way where it would be on number 4, and I always want to use the lowest numbers possible. So I'm going to go with the green numbering system because that gives me the lowest number for that attached group. Now, if there's 2 attached groups and it's a tie, we've got a tiebreaker. So we'll look at the tiebreakers later. Okay, we're not going to get that complicated yet. We'll get the basics down. But there is a tiebreaker. So like if I had one here and I had one here on 2 and 4, should I go 2 here, 4 here, or should I go 2 here, 4 here? And if it's the exact same thing, then it won't matter because it's the same molecule just flipped around. But if I have like a methyl on one and an ethyl on the other, there's a tiebreaker. And ethyl will actually win because alphabetically it's closer to the start of the alphabet. So that's the tiebreaker, but we'll get to the tiebreakers later. Okay, so green is the right way for this one. So this group would be called 2-methyl. because this methyl is located on carbon number 2. Okay? So this name right here is 2-methyl. Now the rules say put a dash between numbers and letters. Put a comma between numbers and numbers. But put a dash between numbers and letters. Okay, so this would be 2-methyl, and we'll just read it as 2-methyl, but it writes 2-methyl. Okay, and then the 5 carbons, that would be called pentane. So this would be 2-methyl pentane. Okay? So number 2, number the parent chain. Give the attached groups the lowest number you can. Okay? So, back to our erroneous molecules here. Okay, so let's see what we can do here. So parent chain on this one, find the longest continuous chain of carbons. Eight. I'm going to go this way.
Yeah.
Okay. Make this a little bigger. Okay, so that's my parent chain. So let's look and see what I have attached. Here is a group that's attached. What would I call that group? Without the number. Yeah, that'd be an ethyl. Because that's a 2-carbon group. How about this one? That's methyl. And this is methyl. Okay? Now, let's number this parent chain so that we get the right numbering system. Okay? So I can start here, and that would go 1, 2, 3, 4, 5, 6, 7, 8. So this would be on number, what do we say, 4, 5, 6, and that'd be 7. Or, if I go backwards, this would be 2, 3, 4, 5. So which way? Backwards, yeah, the green one. The green one would be the right way to do that. Okay, and then we'll deal with the rest of that later, but right now we're just trying to figure out how to number it. Okay? Alright, one more over here. Parent chain. Let's see. Got a couple of choices for the parent chain. It's easier if I go this way. Because if I go over and down, you don't know what to call that top group, so I'm going to avoid that for right now. We'll do that later. It's called an isopropyl group, but you
On
don't
our
know how to
sheet,
do
you did
that
it
right
the
now.
other way. You went over and down.
Oh, I did?
Uh-huh.
Ah! Well. Okay, fine, I'll do it that way. It doesn't matter, it's just whether it's an ISO or not. You just won't know what ISO is. Well, that's because we're just numbering. Okay, so if I go this way, this would be on 2, and this would be on 5. If I go the other way, this would be on 3, 4, 5, and this would be on 6. Okay, so 2, 5 would be lower than 3 and 6. So green again would work. Okay? Yeah, okay, so we've got it in color there, good. Or 2 and 5, sorry. Yeah.
That group is the weird way that you said we don't want the ISO, would that be set properly?
It's
Just ISO.
isopropyl, or you could call it secpropyl, because secpropyl would be the same as isopropyl. Some of them sec and iso are the same, some of them they're not. That one would actually work either way. Yeah. Secpropyl or isopropyl. Yeah, that's later, but yeah. Okay, everybody good on numbering? Parent chain? Hopefully we can all count to 10 or less. All right, step 3 is, we kind of jumped ahead a little bit there. Step 3, name the attached groups. So those things that are attached, we have to name those. So if it's 1 carbon, it's methyl. 2 carbons, it's ethyl. 3 carbons, it's propyl, and so on. We also can throw on some halogens. And there's a whole bunch of other stuff that you can throw on too, but I'll go ahead and throw in the halogens because they're pretty easy. Fluorine is fluoro. Chlorine is chloro. Bromine is bromo. And iodine is iodo. Has anybody ever seen Star Trek Deep Space Nine? Connor has. So the last one is what you would say if you're the constable on Deep Space Nine. Now see, Connor gets that joke. You all haven't seen Deep Space Nine, so now you don't get the joke.
Now I gotta go watch it.
Yeah, the constable's name is Odo. So it's Iodo.
There's like one Family Guy joke you have to see that show to understand. So.
Yeah, and see, I haven't seen Family Guy, so I know. Tragedy things. So fluoro, chloro, bromo, and iodo. Connor and I will get it. The rest of you can just pretend to laugh and figure it out. Actually, you're not missing much on Deep Space Nine. Deep Space Nine wasn't one of my favorite. I don't know. Did you like Deep Space? Yeah.
It's kind of like they're trying to do too much to
Yeah.
the franchise.
It is. Being stationary in one place just didn't work real well. Now once they got the little ship thing to run around in it, it's a little better. Yeah. I don't know. Alright, so anyway, those are the attached groups. Okay? Now step 4 is we're going to put the numbers on those groups, and the number tells you which carbon on the parent chain it's attached to. The number tells you which carbon on the parent chain that group is attached to. Okay, so this methyl group that's circled up here is on carbon number 2 of the parent chain. So this is 2-methyl. Okay? Step 5 is alphabetize the groups. Don't change the numbers. Numbers are different from alphabetizing. I get a lot of people who want to rework the numbers after they alphabetize it. You can't do that. Okay? That's one of the things that at this point is kind of easy to do, is you want to change the numbers. Don't change the numbers. You got to set the numbers first. Then you're going to alphabetize the groups. Now, be sure you alphabetize groups and not prefixes. Okay, for instance, the other day I told you instead of methyl, 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 you'd call it trimethyl. Okay? Don't alphabetize it with the tri, alphabetize it by methyl. Okay? And so you should put those prefixes on if there's more than one of a same attached group. Okay? So if there's 2 methyls, call it dimethyl. If there's 3 chloros, trichloro. Okay? So use di, tri, tetra, etc. for groups of the same kind. And do not consider the prefix when you alphabetize. Okay? And then the parent chain goes last. So Freon is a refrigerant. That's what they put in refrigerators. It's what they put in air conditioners. That's the gas that condenses. There's different mixtures of Freon. Here are 2 of them. Here's Freon 11. Is 1,1,1-trichloro 1-fluoromethane. Okay, so first of all, find your parent chain. Where's your parent chain? Yeah, just this one carbon. That's your whole parent chain. Okay, so the parent chain is called methane. Okay, there's a chlorine on number 1. Here's another chlorine on number 1. Here's another chlorine on number 1. So that would be 1,1,1-trichloro. And then here's a fluorine on number 1. So that'd be 1-fluoro. Now, chloro comes before fluoro alphabetically. So it's 1,1,1-trichloro 1-fluoromethane. This is Freon 12. I've got 2 F's and 2 Cl's. So this is 1,1-dichloro 1,1-difluoromethane. Now remember, you put commas between numbers and numbers, hyphens between numbers and letters, and nothing between letters and letters. So it's difluoromethane. And that is considered all one word. There's no break in that word. Yeah.
So when you're changing elements, is that when you break up the numbers? Like the words from the other numbers?
Well, we've got chloro and fluoro, so we had to break those up.
That's what I meant.
This is just telling you, hey, one of these chlorines is on number 1, and the other chlorine is on number 1.
Okay.
So it's kind of redundant, because if it's 1,1, it's obviously dichloro. So it's a little redundant, but that's what it is. The numbers tell you, hey, the chlorine's on number 1 and the other chlorine's on number 1. So that way it doesn't look like an 11. Okay? So, see if you can draw these. 2-methylpentane, 3-ethylhexane, 2,2-dimethylbutane, and 2,3-dimethylbutane. So take a few minutes and do that. Sketch them out. next will have to block a little deck. Prefixes. Oh, you've got the answers. Oh, yeah.
Yeah, we do, Morgan.
All I've got is what's in there. I don't know if there's anything
Wow.
in there. What?
I said I was actually trying, and still got the answers.
Well, yeah. If you don't try, then you don't get the practice. You don't get the experience.
That top book next to the iPad, there's a pencil in it. So the trick is, if you can't,
Yeah.
Yeah.
The trick is getting it without.
It's like Jenga.
Yeah. It's a giant Jenga.
Almost got it.
No, you actually don't mind.
Well, I'm gonna see if there's any lead in it anyway.
You just kind of throw them off.
Yeah, there's no lead in it anyway.
All
Those
these
twists.
blank spaces.
They're gonna do all that work. I drew the first one.
Yeah.
My pencil.
Oh,
that's right.
Yep.
That's my interpretation, but.
Try to run to my locker to get one.
Yeah, that's fine.
But you pass.
Yeah, it's over there. Yep. Yeah, so you've got the answers there to check, but make sure you can draw these.
We're at the same level, so it's not like you're asking something stupider than yourself. We're at the same level. I'm hating on myself right now. What? You don't believe me, no? You're on the same level. Never mind. What are you saying? You're the one who's being rude now. I'm saying that about the same amount of chemistry, which is next to nothing. If you ask me, that's just a bad choice.
So, we do the power plan.
Because whatever teaches us, we can help each other on.
So it would be halfway.
Well, since you get to draw it, you can draw it however you
So
want.
we can just draw it in a straight line.
So I draw it in a straight line, yeah, that makes it easier.
I didn't know if there was some like.
Yeah, when you're drawing, you get to figure that out. You can decide that, yeah. Cindy?
Also, it says like the two, does it matter like which side the two's on?
No, it doesn't. There's a
Okay.
thing called free rotation, which means that the molecule is free to rotate any way you want. So picking the top or the bottom really doesn't make any difference
Okay.
because the molecule can be rotated any way you want.
And
So-
also the same with like left and right, so like two in from the left and then
Right.
two in the.
Yeah, it's
Okay.
just a rotated molecule.
So, okay.
Now, the problem is, later on, and we won't get into these, but there are actually what we call stereoisomers, And so it's just like right-handed and left-handed. They're the same, but they're mirror images of each other. And so this really isn't the same as this. It's built the same, it has the same structure, has the same stuff on it in the same places, but they're mirror images of each other. And so then you have to decide how you're going to tell which one's which. And there's a system of, okay, if you go this way, it's this, and if you go this way, it's this, to do that. But we won't get into that far. But
Okay.
there is a time when that
I
happens.
think I did this right.
Yeah.
You think you did what right? This. No, all the hydrogens out, I just put them with the carbons, like,
Nope.
it up here.
Nope. You're drawing it, so you get to decide.
Well, that's why I just did CH.
Yeah, now that's different because it attaches in the middle, so it makes a little chain down there instead of a group, and that's where you got to name it differently. Yeah, that was just because of where it was attached.
So if it was attached on either of the end ones?
Yeah, on the ends, then it's just normal, but when it attaches in the middle, that's where you've got to either put SEC or ISO on it, depending on what it is. Yeah, we'll have to do that. Okay, about ready? Okay, let's take a look at these. As I was telling some of these people, there is this concept called free rotation, which means that you can rotate the molecule any way you want. So when you're drawing this, you get to decide whether you put the CH3 above or below, because really all that is the molecule rotated a different way in space. So they're really the same thing. So you get to decide that at this point. On a chain, you know, the easiest way is to draw it in a straight line. And so if you're drawing it, you get to decide, so yeah, I'd put it in the straight line. Okay, so what I would do here is go 5 across, and then on number 2 I'd put a methyl. Now, if you put it above, that's fine. If you put it below, that's fine. And maybe you numbered it this way. So you put the 2-methyl over here, or down here. All of those would be acceptable, because it's the same molecule, it's just rotated. Okay? So on that one, there are 4 different places you could put that methyl. Here, 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 or here. Any of those will work. And so one of the things in organic is we don't always get the same answer. It is the same molecule, but we might draw it differently, because we might have a different perspective on it. So, you know, our answers aren't always just exactly the same, even though it's the same molecule and built the same. It is the same, it's just we didn't draw it the same. 3-ethylhexane, again, I would go 6 straight across. And then on number 3, put an ethyl. And if you put it here instead of here, that's fine. That just means you counted the other way. Okay, and if you put it below instead of above, that's okay too. So again, there are 4 different ways you could draw the same molecule, depending on which way you turn it.
Can we do the shortcut way, or do you want us to draw all the attached hydrogens?
I will leave that up to you. You cannot just dump the hydrogens. You can either draw out every single hydrogen, or you can use what we call the condensed formula, which is where you just write down how many hydrogens there are.
Okay.
The other way you can do it is you can actually just draw the sticks and assume that there are hydrogens. So some people like that. They'll draw all the sticks, but then they don't write the H's. That'll work too. H's are assumed. But there has to be some way to show how many hydrogens are there. Whether it sticks or whether you just put a number on it or whether you draw them all out, I will leave that up to you. Okay? One of the worksheets we're going to do is going to make you run through all of the combinations so that way you recognize all the combinations, but when you draw it, then you get to decide. Okay? All right, 2,2-dimethylbutane would look something like this. Okay, I'd go 4 straight across, just to make it easy. You don't have to. And then methyl on 2 and methyl on 2. Now, this is where sometimes we get people confused a little bit. There's a difference between 2,2-dimethyl. There's a difference between 2,2-dimethyl and 2-ethyl. Since this is 2,2-dimethyl, I have to put a methyl on one side and a methyl on the other side. Ethyl would be 2 carbons on one side and nothing on the other. So you have to watch out for that. Sometimes that messes people up. There's a difference between dimethyl and ethyl. Ethyl is a 2-carbon group that's attached one time. Dimethyl is a 1-carbon group attached twice. So there's a difference. And then 2,3-dimethylbutane, you just move one of the methyls over. And again, if you went above instead of below, that's fine. If you put them both on the same side, that's fine. If you put them on opposite sides, that's fine. Okay, is this starting to make some sense now? Because a couple days ago, y'all were going. Okay, so we're making some sense here. Good, good. Yeah, now this is what we were just talking about, different ways to draw it. Structural formulas are lazy ways to write the hydrogens. You just write the number of hydrogens and you don't draw out all the sticks and all the H's. Okay? And that's perfectly fine. That's called a structural formula because it still has the structure to it. It's just you don't draw all the bonds and all the H's. Okay? But again, remember the bonds are between carbons, not between hydrogens. So here is 2-methylpentane in a structural formula. Here is 2-methylpentane in a true full Lewis structure. Okay, that the H's are all drawn out. Okay, so structural formulas are fine. I don't care, but I just want to make sure that you realize that those H's are not in that carbon chain. They have to hang off of it. They're not in the middle of that chain. Okay. Now, tiebreakers. I started talking about tiebreakers a little bit. What happens if you get a tie like this one? Okay, well, there's a thing called priority, and I'm going to give you a sheet that runs down the priorities for you once we start getting a whole bunch of them. So that way you don't have to memorize the whole list, okay? But we're just going to need a couple of tiebreakers for right now, so I'm not going to give it to you just yet, but we will. But in a tie, halogens get the lower number before carbon groups do. So here you have a molecule, is this 4-chloro-2-methylpentane or 2-chloro-4-methyl? Because it's a tie. You see how it's a tie? Because if you go this way, it's 2,4, and if you go this way, it's 2,4. Now, if the numbers aren't forcing this into a tie, then you got to go with the lowest numbers for the groups. Okay, so if it's between 2,5 or 3,6, that's not a tie. you go 2-5. Okay? But here, either way, it's 2-4. So in a tie, halogens get the lower number. Patrick?
But wouldn't it not end up mattering at all anyways?
Oh yeah, it will.
Free rotation, it's still going to be in those same positions.
Well, they can't, well, yeah, I mean, you can rotate the molecule, but as far as the name goes, we do need to establish that. We do need to establish which way you're going to count
You
it
could just
from.
do it 180 and it'd be the same.
Right, but when you come along and do a reaction later on, and then you've got to say, you know, which one it's going to attach to, and so yeah, that's kind of setting it up for later. But yeah, you do need to establish that though. Yes.
So if you had sort of like a really long chain and you had like something on the 2, 3, and then there's a space and there's like a 5, you just do the number of the two that were right next to each other. Would that come first because
It's the set of numbers. So if it's 2, 3, 5 versus 2, 3,
2, 4, 5.
2, 4, 5, then 2, 3, 5 would be lower.
That's I wasn't sure if the
Yeah.
was just
Yeah, you're absolutely right. Yeah. So which one would this be? 2-chloro. Yeah, it would be the bottom one. Because chlorine wins the tie over a carbon group. Okay? So halogens win ties over carbon groups. Now what if they're both carbon groups? Or what if they're both halogens? Then the tiebreaker is alphabetical. So if it's a tie between similar groups, the group lower alphabetically, closest to the front of the alphabet, will win. So here you have 4-bromo, 2-chloro, or 2-bromo, 4-chloro. Well, it's a halogen versus a halogen, and so that tie is another tie. We've got to go to the second overtime, okay, because we've got a tie for the first. Now you got to go to the tiebreaker for the tiebreaker. And the tiebreaker for the tiebreaker is alphabetical. So 4-bromo, 2-chloro wouldn't be alphabetical. 2-bromo, 4-chloro, that would be alphabetical. But regardless, you write it alphabetical. Okay? That's where I say don't get the numbers mixed up with alphabetizing. You have to set the numbers before you start alphabetizing. So notice they didn't write the top one 2-chloro, 4-bromo. It was still bromo first and then chloro, but they had to decide the numbers. Okay, so that's what you do in the case of a tie. All right, making sense. Okay, we're gonna spend the rest of the week basically practicing. Okay, so I'm going to give you some today to name and to draw. Work on it some today. Tomorrow we can go over some of them and work some more. Okay, not trying to stress you out, not trying to give you a bunch of stuff to take home, but you've got 10 minutes. You can name a few and draw a few, get some practice in, and then tomorrow we can do some more. Okay, so let me give you a few to practice.